Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad LUQMAN bin Muhammad SAFU'AN from section 6, and my matrix number is AA191101. My partner name is AHMAD bin ZURIMAN, and he's from section 6 also. Okay, now today we're going to explain about the lab activity 4, which is electro-pneumatic and electro-hydraulic system. Okay, me will do the activity 1 and activity 2, and Ahmad will do the activity 3. Now let's move on to the lab activity 1. As you can see here, we have two circuits, which are the electro-pneumatic and electro-hydraulic circuit. For the both of the circuit, first of all, we need to set the cylinder stroke to the 200mm. And next, screenshot the complete diagram. Okay, now let's take a look to the circuit that FI do. First of all, we go to the pneumatic circuit. Okay, this is the pneumatic circuit. Okay, now let's run the circuit. Okay, we have run the circuit. As we can see here, the air is flowing from the air supply through this part and cut off here at the rest time. Then, which the air does not flow up to the cylinder, but when we press the valve, the air will flow through this part and fill up the front part of the cylinder. So when the head of the piston hit the 1B1, yes, the switch from normally closed will become open. Okay. And then when we left the valve, the switch will become closed as soon as the head of the piston left 1B1 labeled part. The other way to make the cylinder move by push the S1 switch. When I push the S1 switch, okay, when I push the S1 switch, the current will flow through here, and this K1 switch will become closed, and solenoid I1Y will energize and make this valve move to the right, as we can see here. When the piston, as I mentioned before, when the head of the piston hit 1B1 area, this 1B1 switch from normally closed will become open and make the K1 relay de-energized, that making this switch to become open. It will stop the current flow to the solenoid valve, and the valve here will back to the original position where it doesn't allow the air pass through it and go to the cylinder. So this is how this system works. Assalamualaikum warahmatullahi wabarakatuh. Now we move on to the next circuit, which is the electro-hydraulic circuit. So as you can see here, this is the circuit. Firstly, we must check the parameter and set to 200mm stroke. Now we run the circuit. Okay, we have run the circuit. As you can see here, the water is flow from the supply to the back part of the valve, and it is not going to the cylinder at the rest time, which is now. Okay, next, when I normally press the valve, the water will fill up the upper part of cylinder, the piston at 1B1 position. Okay, as we can see here, the water will flow up the cylinder. Okay, next, this 1B1 switch from normally closed will become open. So when I release the valve, the fluid from the cylinder will flow through this part and fill up the tank here. This is how the tank will fill up when I press the valve normally. Another way is by electrical move, which is when I press the S1 switch here. Okay. That is by electrical move. The current will flow through this part and will pass by 1B1, which is already closed, and make the K1 relay coil energized, and both the K1 relay contacts will become closed. Next, the 1Y solenoid valve will get energized and make the valve move to the right, but the system will only until the piston reach at 1B1 position here. After piston reach at 1B1 here, from normally closed, switch will become open and making the relay coil K1 de-energized, and both the K1 switch will become open. The solenoid valve 1Y here will also de-energize, and the valve will go back to the original position, and making the fluid from the cylinder will fill up the tank. Okay, as we can see here, once I press the S1 switch, the piston will contact and extract in one action. Okay, we don't have to push it again to make the piston come back to its original position. So this is how the electro-hydraulic system works, and this is how the fluid is filling up the tank here. Okay, now I'm gonna explain about the observation for activity 1 and the question for activity 1. Let's move on to the observation first. Okay. Number 1, briefly discuss the function of the two components circled in red below. Okay, this is the tank. A tank in a hydraulic system is a container that holds and stores the fluid required to supply the system, as well as reserves to offset any losses due to minor leakage or evaporate. As a result, this tank can be built to offer space for flight expansion, allow trapped air and the fluid to escape, the aid and the cooling of the flight. Okay, next, this one is the air compressor. It is a pneumatic device that converts power into potential energy stored in pressurized air, such as compressed air. An air compressor forces more and more air into a storage tank, raising the pressure until the tank's pressure reaches its limit, at which point the air compressor shuts off and the compressed air is retained in the tank until needed. Okay. For the question number 1, describe the difference between electro-pneumatic and electro-hydraulic system. Basically, these two operations is the same. The difference are actually in electro-pneumatic circuit, the energy sources is air from the air compressed, but in electro-hydraulic circuit, the supply is a tank which is using fluid to as the supply, and in electro-pneumatic circuit it using air the supply. Next, electro-pneumatic system have low pressure, but electro-hydraulic system has high pressure. Okay, for the next question, describe an industrial application for electro-pneumatic and electro-hydraulic system shown in figure 1. The pressurized air used as a working medium is controlled using electrical technology in an electro-pneumatic system. Solenoid, limit, switch, valve and relay are examples of electrical devices utilized in a conventional electro-pneumatic arrangement. Electrical power is applied to a directional control valve. In industry, automation technology (ATI) has introduced an electro-hydraulic control system, adding to its range of valve actuators and controls, so the product can be directly mounted to a linear or quarter-turn spring return or double-acting actuator to perform critical shutdowns, even when a power source is unavailable. The electro-hydraulic system can be provided for either non-hazardous area or hazardous area related service. So the electro-hydraulic circuit consists of a power module and control module, an electrical motor, a single direction hydraulic pump with reservoir, a valve manifold and power supply for control components make up the power module. Now we move on to the lab activity 2. Okay, as we can see here, the left side is the pneumatic diagram and this one is electrical diagram. We must construct this circuit to the fluid sim software like this one. Okay, now to run the simulation we must click the button here. Then as you can see here, let me explain the electrical diagram of this pneumatic circuit. Basically, as we know, 1B1 and 1B2 is normally open limit switch. Whenever it reaches the limit, the circuit will become open circuit. When I push the push button here, which is S1, the current will flow through it and it is going to energize the relay coil over here at K1. Next, when K1 is fully energized, the switch here will be triggered and become in a close contact. As you can see here, here is the limit switch. Whenever the limit switch operates, is going to energize the relay coil over K2. Here got switch. When K2 is fully energized, the switch over K2 here will become closed. And when K1 and K2 in closed circuit, 1M1 will be triggered and it's going to move the actuator over here. Same goes to the 1B2. Whenever it reaches the limit, it is in an open circuit and this one also operates the same way. So whenever 1B2 is in closed circuit, the K3 relay will be energized and the K3 switch will become in a closed circuit and is going to trigger 1M2 and is going to operate repeatedly. Finally, let's try the simulation. When I repush the push button, the operation will stop and the cylinder will become in the original position. Okay, that's all from me. Now we move on to the observation for the lab activity 2 and the question for activity 2. Okay, this is the pneumatic diagram and electrical diagram. Okay. For the observation number 1, state the name of component 1B1 and 1B2, which is this one and this one. Okay. As we can see in the electrical diagram, 1B1 and 1B2 is a limit switch where 1B1 is normally open limit switch while 1B2 is a normally closed limit switch. Next, briefly discuss the function of 1B1 and 1B2 in this circuit diagram. Okay, these both switches are limit switch. The function of the limit switch is to control the machinery as a part of a control system. 1B1 and 1B2 used to control the electric current flowing through them. When the switch S1 is pressed, so both 1B1 and 1B2 will let the current flow when the amount of current flowing through is between the range of the current that the circuit or the system can handle. But when the current is exceeding the limit switch 1B1 and 1B2 will prevent the current from overflowing, and that is the function of 1B1 and 1B2. Okay, for the next question, during simulation, a symbol with an arrow always appears next to a component in the electrical diagram. Describe what do you understand when you see the symbol. Okay, when we run the circuit and when we push the button, the symbol will appear. Okay. I understand that the symbol arrow pointing outwards will appear at the components that are in work. When the current is flowing through the component, the arrow will appear beside the components. The arrow will never appear when the current is not flowing through the component, which is, for example, when the switch at the component is open, so the components in line with a open switch. So I can see that the arrow will appear when the current flow through the components and will gone when the current is not flowing. Okay, next we move on to the question number 1. Discuss the importance of component A in actual industrial application. Okay, component A is this one. Okay, it is actually an air service unit. It represents a compressor in a pneumatic circuit. The function of compressor is to remove dust particles, humidity, moisture, and so on from the compressed air, and there are several parts in the air service unit, which is also called as air preparation system. The first one is a filter, which is it removes the impurities present in the compressed air supply before it is delivered to pneumatic components. Then the second one is pressure regulator, which is it allows us to regulate pressure manually, and the last one is lubricator, which is it provides lubrication for pneumatic components. Okay, that's all from me. Thank you.
Assalamualaikum, my name is AHMAD ZURIMAN. My number MOHD is AA191485. I'm from section 3. Now I will explain for lab activity. This is a electrical diagram and this is a pneumatic diagram. These two diagrams are linked in some way. First and foremost, we can see that the pneumatic connection has been made as well as the electrical diagram connection. Now, to gain a deeper understanding, the wave is already in the left position from here. As a result, we manually push the wave to the right order for it move. After then, we can observe that compressed air has already made its way into a space. As a result, the piston is linked to rest. Now we look at electrical diagram. The link has already been established, and this is a switch. So if you press the detent switch, it will make a connection. The circuit has now been complete. As a result, we can see that there is a counter here as well. The number 5 has been set as the counter. Now let's look at the pneumatic game and see what we did after moving the wave to the right. Now that the compressed air has been passed into this cap, the piston will be expanded and the residual air will be sent to the exhaust. Now looking at the electrical diagram, we can see the counter has been set to 0. The counter has now reached 0. We push the S2 key to reset the counter to 5 once more. The counter will then be set to 5. That is how the pneumatic diagram and electrical diagram circuit diagram function. After that, for solution 1, tabulate the list of components used in figure 3. Compressed air supply, air service unit, 5 per N wave and double acting cylinder are the components utilized in the pneumatic diagram. We utilize electrical connection 24 volt, 0 volt relay counter with solenoid, make the switch, brake switch, push button, detent switch, and magnetic proximity switch in the electrical schematic. For observation 2, explain the function of S2. S2 will operate as a rest button resetting the counter from 0 to 5. Then for the question 1, the position of 1B1 and 1B2 in figure 3 is different from figure 2 by referring to the component A and B below are both tight particles for the 1B1 and 1B2 in figure 3. Explain your answer. The position of component A and B are actually the same. So between these two lab activities, we may conclude that they both fulfill the same objective. However, due to how they work, the limit switch and the magnetic proximity switch may differ slightly. So their component A is a limit switch. The motion of the operation lever can be used to operate it mechanically. The magnetic proximity switch, on the other hand, it contains a reed switch indicate the magnet closeness. And the proximity switch is commonly employed and operates as a result of an electromagnetic field disturbance induced by capacitance or by sensing a magnetic field. So based on what we learned, both types are useful since 1B1 and 1B2 can truly serve the same purpose. They can truly serve the same goal, and the electrical and pneumatic diagram are linked together.